And now for something completely different. We are going to work on making an agent that knows how to code, how to write Python code, how to write software. And a little bit more than that, it's not only going to know how to write software, but how to run it as well. So this is challenging and complex, but it's possible to have an agent in the Crew environment, which has this ability. Not only is it able to take a problem that you set it, it can write code to solve that problem. It can then execute that code in a Docker container. It doesn't need to, but it's good to have it run it in a Docker container, which means that it is in a sort of sandboxed, ring-fenced environment that doesn't have access to do damage to your computer because it's in this protected world. And then it can run the code, it can execute it in that container and look at the results and interpret those results to take on some more action. So as I say, this is a really advanced task. This is something that's taking us to the next level, and it's going to be hard and complex, except it's not going to be hard or complex. You probably saw it coming. But it is going to be as simple as when we create an agent, we're going to say allow code execution equals true. And that's going to be it. And then it's going to be able to execute code. And if you say code execution mode equals safe, then if you have Docker installed on your system, and I will show you how to install Docker if you don't, it will run it in a Docker container. And it seems almost so good. It's crazy. I had to close down Docker to make sure that it failed when it was closed, because I almost couldn't believe it was happening. It's that simple. And this is where frameworks like Crew really stand out, because they make things like this so very easy to do. It's worth mentioning that this kind of system is sometimes called a coder agent. There's various other names for it you hear. And it's worth knowing that when people talk about coder agents, they're not just talking about agents that can deliver code, agents that are able to generate Python, but also this ability to generate Python and then run that Python as steps towards solving a greater problem. So that this is more a means to an end than just saying it is something which writes code. Now, confusingly, our project for this week, we are going to build something that writes code, but the fact that it can run it too is kind of cool. So that is the introduction. And with that, let's go and actually build something like this. Let's build something that can write it. We'll make something that can write code and can run it. Let's do that. See you in a sec. Okay, welcome back to Cursor. Welcome back to the Crew folder. And I'm going to open up a new terminal and go into that third folder. And you know how to create a Crew project so well now that you have it committed to memory, but you know that it's CrewAI, which I can't spell, CrewAI, create Crew, and then the name of the project, which we will call Coder. And it's going to build the directories. It's going to do the scaffolding. Oh, we have to say that we want OpenAI and we want GPT-4o Mini and we don't need a key. And kabam, we have all of the folder structure. Great. Okay, so as always, the first thing we do is we go into the config and we start by defining our agents. So what agents are we going to have? We're only going to have one this time. It's going to be a very simple agent. Let me just remove this so that we can see what we're doing. Let's delete the scaffolding and put in our coder agent. So we're going to say you're a Python developer. That's the role. You write Python code to achieve this assignment. And then we pass in the assignment. That is the input that will be set in the run method. First, you plan how the code will work. Then you write the code. Then you run it and check the output. Backstory, a seasoned Python developer with a knack for writing clean, efficient code. And we can use GPT-4o Mini. Yes, you can do it either way, but we'll do what Cursor suggests. Change it to have the provider and the name of the model, which looks a bit better. Okay, so there we go. That's pretty simple. That was our single agent, and we're going to have one single task. Let's put it in here. It is write Python code to achieve this assignment. A text file that includes the code. So the output we want from it is a text file that includes the code and the output of the code. We want it to put both in the output. So I've called it code and output.txt as the output. So that is what we want it to do. So that's because I really want to make the point that it's going to write code, run it, get the output, and it's going to think all of this through and then respond with all of that. We don't just want it to give us the output because we want to double check what it's doing is right. Okay, now we know we have to go to the Crew module. Let's do that next. Okay, here we are in the Crew module that I've just gone through and deleted the templatey stuff that's in there by default. And so we're just leaving our config relationships here. And I'm just going to put in a little comment here. Make that a comment as well. Whoops. So this is a link to how you can install Docker if you don't already have it installed. And this, it's just literally, this is the Docker desktop web page for you. And as it does claim, it is a one-click install for Mac or Windows or Linux, and it should be as simple as that. Many of you, I suspect, from an engineering background already know and love Docker. If you don't, then welcome to it. This should be as simple as installing it, and then it's installed, and you can then leave it be. But you will need to have it installed for this to work properly in a Docker setting. Okay, so now we are going to create our agent. We start with an agent decorator to make sure it goes in the right place. And we are going to create a coder. I'm going to ignore the fact that cursor is already probably several steps ahead of me, rendering my job here useless, but we'll keep going anyway. I'm going to return an agent. This is the usual fare. So what is our agent going to do? Well, we'll press tab there. The config is going to be the config that we set in the YAML file, but then we'll have verbose being true as usual. Now, what else do we want? We now want this super complex, super hard step of making sure that this agent has the power to run, to execute code, which is as simple as allow code execution equals true. There it is. Now it can execute code. There's this step of saying code execution mode is safe. And now that ensures that it runs it within a Docker container so that it's not just running the code on your platform. Now we can say max execution time. This is a good one to have in there. And we're going to say 30 seconds. This is going to be a simple task. And max retry limit. It's funny that cursor prompted me wrong there. Let's give it 5 retries. It can have up to 5 times of trying this. And that is our coder agent. So now we have a task, and the task is going to be a coding task. And I rather suspect that we can just use what cursor does, but we can take out expected output because we already defined the expected output in the task itself. So that's not needed again. All right, so there we go. We have our agent and our task defined. Now we just have to do the crew function method just below. Well, this might be a bit of an anticlimax of just saying we have to write our crew function. We don't have to write our crew function because the default thing there is all that we need. We don't need to do anything else. We've already got something which can do exactly what we want. What we do need to do still is come into main and rewrite this. And of course, it's got all of the usual stuff. We don't need any of the stuff that's there. We'll just delete everything and come back here and write our own run function. Def run. This is the thing that's going to run the crew. And so we are going to say inputs equals assignment. How do I spell assignment? Assignment. There we go. Colon. Let's just give that a variable assignment for now. And then we're going to say results equals coder dot crew dot kickoff, passing in those inputs. And then we want to print result.raw is how the result will come back. And then we will indeed have, no, we don't need that main in there because it will automatically run that for us. Okay, and so what's left to do, of course, is to set the actual assignment. So let's come up with assignment. Assignment, and we're going to do something challenging here because I want to check. If I said something like the default the cursor's got for us there, write a Python script that prints hello world, then we might not know for sure that it's actually running it because LLMs are perfectly capable of knowing what a script like that would yield, would result in. So it could generate the Python code and then pretend it ran it. So we want something that it can't do any pretending for. And so I have one thing to show you, although knowing LLMs, it probably could pretend this as well. But I certainly think this is a harder one. So I wanted to write a Python program to calculate the first 10,000 terms of this series, multiplying the total by 4. So I put it in quite a complicated way. And here's the series. 1 minus a third plus a fifth minus a seventh plus ... And so I'm just kind of, it's a classic case of just sort of asking the LLM to figure it out like a reasonable, intelligent human would. And who would have thought a few years ago that you could write software that would be able to take something like this with all of the nuance, all of the implications, and figure out that it needs to write code to put this into a loop to keep it going for 10,000 terms, and then to take the total and multiply it by 4. And the Mathmos around will probably have already spotted this as being a very slow and very boring way to calculate pi. So if it does this right, and if it calculates the first 10,000 terms and multiplies by 4, then it will be an approximation, a bad approximation of pi. And now, the LLMs are perfectly capable of recognizing this formula and knowing that the answer should be pi. But what's much harder is for them to realize that 10,000 terms would be approximately pi. It would be wrong after a few decimal places. And so that's how we can tell that it's really doing its thing. So I hope that all makes sense. It's time for us to actually run this. All right, everyone, this is exciting. The drum roll, we're going to try and have our coder do its thing. So let's bring up a terminal. Let's go into the third directory. Let's go into Coda and let's type CrewAI run to kick this off. And remember, the challenge is now being set to our agent. You can see it started. There's the command, and it's now going to be thinking about it. And something just ran and failed in the code interpreter. So it's that one means it's its first try, and it's trying again. So it's not like it always works. At least it shows us that something is trying to run in an interpreter. Okay, it's done some code, it's got an answer, it just all happened really fast. So this is the code that it's got, that it's written, and this is the output. It's used an interesting technique. I can see it's obviously it's going through the number of terms as it should do. It's and a number of terms it sets down below. That's nicely done. And then it's using this idea of take -1 to the power of the index, which is either going to be -1 or +1. That's a clever trick. And dividing by that, which looks right to me. And then where do we see it multiplying the result by 4? There, right there. I was going to say that would be suspicious. It does indeed multiply the result by 4, and that's why we get 3.14149, not 3.14159, because it is just an approximation of pi, and it seems to have worked. And indeed, if also we see that it's created an output file. Yes, it has. And here in the output file, we will find the same output, which has got the code, the output below it. And I got to tell you, I'm blown away by how easy it is to do this, and all of the machinery that's happening behind the scenes to be able to start a Docker container, come up with the code, run the code, come up with the answer, to the way that I expressed it in quite a simplistic way. It just figured the whole thing out. And I think that's really cool. And there you have it. We just gave coding skills to an agent. We have our Coda agent, and it was so simple. And I hope you enjoyed it as much as I did. All right, well, it ain't over yet. We've got more to go, because the natural extension, now that we've got a coder, we can build an entire engineering team. It's really, there goes in the meaning of crew. We're going to build a crew, an engineering crew, to be able to solve problems front to back. And it's going to be so great. I'll see you then.